So we have the intermediate value theorem. I've talked to you a little bit about how it relates to the speed of a car. If you're going 60 miles per hour at one moment in time, 2 minutes later we see that you're going 80 miles per hour. How we pretty much guarantee there exists a moment in time between the first time you looked at the speedometer and the second time you looked at the speedometer. You had to have been hitting every single value between 60 and 80. So I guarantee there's a moment in time you had to be going 71 miles per hour. I guarantee there's a moment in time you had to be going 75 miles per hour. That's kind of a real-world explanation of the intermediate value theorem. Up here you'll see the mathematical description of intermediate value theorem. It's saying if f is a continuous function on the interval a, b, a closed interval a, b. So graphically, here's what that would look like. If here's a, here's b, I guarantee you f is continuous on that closed interval a, b. So here would be an example of a continuous function on the interval, on the closed interval a, b. Everybody agree? Yes. Okay. It also says that f of a does not equal f of b. So in other words, this y value at the beginning does not match the y value at the end. To relate that to my speed situation, basically I had two different speeds. The first time you looked at the speedometer we were going 60. The second time we looked at the speedometer we were going 80. Those were different values. That has to be the case. Because if you saw 60 and then 5 minutes later you saw 60 again, you can't guarantee me you were going any speed other than 60, right? Okay? So they have to be different. So f is continuous. The y values here have to be different. So here's f of a. Here's roughly f of b. And then k is some value between f of a and f of b. So I could put k pretty much anywhere between these. So if f is a continuous function on the closed interval a to b, f of a does not equal f of b, and k is somewhere in between there. The intermediate value theorem basically says that there has to exist some c value between a and b. There's got to be some x value on this interval such that f of c equals k. And roughly that looks like it would occur about right here on my picture. Okay? F of c has to equal k. That's what the intermediate value theorem is basically stating. If f is continuous on a closed interval, I guarantee you that we have to be able to have some c value on that interval such that f of c equals that k value. Going back to the speed thing, I guarantee you there must be some moment in time you were going 72 miles per hour. I guarantee you there must be some moment in time you were going 77 miles per hour. And that's kind of the intermediate value theorem in a nutshell. Okay? Yes, no, questions? Okay, go to page 80 in your textbooks. Page 80, problem number 83. So problem number 83 gives you this function right here. And it basically says, guarantee that it has a 0 on the interval 1 to 2. Explain why this function must have a 0 on the interval 1 to 2. So this would be an example where we can use the intermediate value theorem to help us guarantee there's got to be a 0 on the interval 1 to 2. Okay? All right. Well, first of all, let's see if we can use the intermediate value theorem. Is the function continuous? From what you know about that function. Does this function have any breaks in it? Any asymptotes or things like that? It's a nice polynomial. Okay? You can plug in any number for x. You can get different answers for y. It's a continuous function. The domain is all real numbers. You can plug in any number you want. Okay? So I would say, first of all, f of x is continuous. All right? You got to make sure it's continuous, otherwise we cannot use the intermediate value theorem. Okay? So it's definitely continuous. We need to also show that f of a does not equal f of b. So in this case, we need to show that what? F of 1 does not equal f of 2. Okay? So f of 1, that'd be 1/12 minus 1. So we're at negative 11/12 plus 4. That would be 3 and 1/12, or I believe 37/12. Okay? F of 2, 2 to the 4th is 16 times 1/12 would be 16/12, 4/3. 4/3 minus 8, that'd be 4/3 minus 24/3, that'd be negative 20/3, plus 12/3, I think negative 8/3. I hope I'm right. On video, I look like an idiot. Okay? 4/3 minus 24/3 would be negative 20/3 plus 12/3, negative 8/3. Yep.
They're not equal, so we're good.
Okay? So they're not equal. All right? So how can you guarantee me that there has to exist a 0 now on this interval? A 0 is where the graph does what? Crosses the x-axis. How can you guarantee me there has to be a point where this graph crosses the x-axis on the interval 1 to 2?
You have a positive and a negative.
Perfect. If at 1 we're at a positive value and at 2 we're at a negative value, what had to happen? Had to cross the x-axis somewhere, at least once, right? Because we know that as we go from f of 1 to f of 2, if I go from 37/12 to negative 8/3, I had to cross the x-axis. So by the intermediate value theorem, there must be some value such that f of c equals 0. This would be kind of how I would want you to answer this particular type of question. You're verifying it's continuous, you're showing me these values are not equal, and then the intermediate value theorem says we have to hit any value between here, and 0 is definitely between here and here. So I guarantee you the intermediate value theorem says there has to be some point such that f of c is equal to 0. I didn't ask you to find that point. I'm just asking you to verify that there has to be one. Is this logical? Does it make sense? Do you have any questions? So if I give you a question like this and say, guarantee me it has a 0 between 4 and 9, you would know what I'm looking for as far as an answer goes. Okay? This is what I would want you to do. I want you to state that it's continuous. Okay? If you want to know, okay, well, how do you know it's continuous? Well, in this case, because it's a polynomial. Alright? So, make sure you state it's continuous, make sure you find the f of a and f of b values, make sure they're not equal, and then the intermediate value theorem pretty much just guarantees that you hit every number between those two line values. Okay? Alright.